Hello. Today we're going to talk about multi-cloud VMs and a single control plane, OpenShift virtualization with Advanced Cluster Manager, and how that can bring the ability for you, your organization, and your engineering teams to be able to deliver a multi-cloud environment with a single pane of glass view, and that ability to move between on-prem and your hyperscalers of choice. What we're going to talk about today, why VMs still matter, the cloud drivers and economics behind these things, Kubernetes native virtualization, where we are, where it's going, portability, and the open hybrid cloud, and why multi-cloud virtualization should be your choice right now. We'll jump into a demo. Currently, companies need to preserve their VMs. There's a lot of commercial off-the-shelf software out there that can only run within virtualized environments or on operating systems. There's a number of legacy applications that organizations still require, that these suppliers have either gone bust, disappeared, or even refused to move to containers for whatever reason. As you can see, the segregation, the split here of bare metal, VM, and container. And while we're seeing that container is slowly creeping up, there is still an incredibly large level of virtual machines. And I suspect any of you, if you dig into your organizations, will find that there are a number of VMs either sat on-prem or somewhere in your hyperscaler running on a virtualized instance there. There's an opportunity out there for you to be able to address the issues you have, and potentially you have an incumbent virtualization provider that's causing problems. But you could match that with a very similar interface, a way to overcommit your VMs, just like you have done, just like you will have done for a long time, but start that journey to modernization by running your virtual machines within an environment that accepts VMs as much as it accepts containers. Why should you consider running VMs in the cloud? A lot of organizations are talking about data center exits. They're looking to remove the burden of having to buy their own hardware. And as we know at this moment in time with the AI pressures, it's very difficult to actually renuke it. There are 6 to 12 month wait times, according to some of the customers that we speak to. Scale to the cloud, that ability and what the cloud was built for, the ability for you to right size your environment at the right time, be that scale up, scale down, depending upon the workloads that are happening or the users that are consuming your services via the web. Application modernization. There is a move. There is a move to be more cloud native. There is a move to containers, but that doesn't mean you can do that with every single application that you've currently got. Over provisioning and sprawl, major sources of cloud waste. We constantly have conversations as specialists with organizations where there is a complaint about their cloud bill, and there's a lot of effort that teams put into being able to right size the virtual machines they use, being able to make sure that things are scaling up and down. But then they also need, you have a committed spend agreement, you need to cover that kind of up. But also then forecasting your spending. FinOps is a massive thing, and most organizations are picking up the value that can bring. And that's all the top 3 that are there. And utilizing managed services, managed OpenShift in the cloud with your VMs can help you align with all of this, reduce your waste of underutilization of your VMs, optimize your workloads, the overcommit, utilizing the bare metal nodes they got, still while committing against your spend for your hyperscaler, but also being able to reduce far more accurate spending, but also labeling up. So you can cross-charge the departments that you need. All of these things, I suspect, you're asking your engineering teams and your managers to be able to provide you the information with. What's leading to your overspend? We, recently through a lot of the Virt migration that we've done, we've realized how despite the levels of optimization organizations have put in, there is still a huge underutilization of their virtual instances. But then there's a lack of individual team responsibility, sprawl, a lot of things that come down to the way engineers behave, which is already built into OpenShift, be that cloud or virtualization. But with virtualization, you can bring that over provisioning that you were used to previously. How busy are your virtual machines? And here's some times here of the amount of hours that go into in a year. And are your machines being used to the best of their capability for all of those hours that they need to be? Averages, yeah. And this is not stuff that we've just made up. This is where we've actually gone out and spoken to customers. Shared capacity, scheduling and all of that. But if you have a look here, that it becomes very, very expensive if you are not utilizing your instances to their full capability. And the bigger the organizations and the more services you have, obviously the more opportunity there is for you to save large quantities of money. But if you have a look, let's just take manufacturing. The low levels of utilization there that maybe OpenShift virtualization could help them with. Optimizing your strategy. Large footprint of VMs. There are many organizations running multiple VMs all at the same time because they've got across different environments, often into the hundreds, often into the thousands with recent conversations that we've had. But this is kind of growing the cloud spend, and no matter how much you squeeze down your VMs, it's very difficult to get the full optimization out of them. So that starts then to increase the cost per VM as the estate grows and line items become excessive. But also the push for the data center exits. A lot of data center exits have landed organizations to just using EC2 instance because there's a sudden need to get out of there. But then there's also a modernization push. And for a lot of orgs and a lot of, I suspect, your organizations and your teams, you are asking your engineering teams to also deliver on modernization while they're still supporting old virtual machines. And it's how can you align the two so that you most efficiently deliver what the organization needs at the right value. Opportunity, high density virtualization. Like we say, we talk about the fact that people are lifting and shifting out of their on-prem data centers and into the cloud. And that kind of removes the ability to overcommit that you might have been accustomed to with your hypervisor on-prem. But here we have a shared platform capacity. You don't treat every VM as an isolated incident. It sits on top of a cluster, and you can overcommit. You can overcommit your memory. You can overcommit your CPU. You can control the way that is done, allowing the workloads that need that breathing space to be able to do it, but also then allowing much more freedom in your pre-production environments, for example, where that ability to much more greatly overcommit is not going to affect the end customer. And what does that mean? That means that you can run your existing and potentially new VM workloads more efficiently, utilizing tools that are native within a Kubernetes environment, within OpenShift itself, to actually squeeze things better together, to right size your cluster and to right size the number of VMs that are running on there. This is not new. This is not new to Red Hat. This is certainly not new to OpenShift. We come from the introduction of KVM, one of the very original Linux-based hypervisors, and we've grown through OpenStack, and then we've landed OpenShift virtualization, leveraging KVM and KubeVirt in 2020. This is 6-year-old technology. We're not talking about anything new. So you have the ability to trust what's there. You have the comfort knowing that this is not new technology. This is well-worn technology utilized and run by many, many large organizations. KubeVirt itself is very mature. One of the top 10 CNCF active projects, because virtualization is such a thing and it needs to be thought about in terms of the way cloud native works. There's over 200 companies contributing towards this, 60 releases. The intensity and the number of contributing companies, because there's the vision of the value that this brings, is increasing quite rapidly. Who uses it? It's not as if there's it's small companies out there. There are a number of very large names on this slide that should give you a little bit of comfort that it's not just us saying how powerful this is. It's not just us saying you should be using it. Here are a number of end users and vendors that have taken on and started to utilize, build upon, and drive out KubeVirt itself. A prime example, NVIDIA, a company I'm sure you've heard of, utilize it for their on-demand gaming cloud. As you can imagine, that puts a lot of stress on both clusters and the way things run. But 28 million users, 1,500 games across 100 countries, across 30 plus data centers. I repeat, a well-proven, well-worn path for your technology. Open hybrid cloud portability, what I really like to talk about here and what can bring you huge advantages. You need to be able to move apps to comply with new regulations, new rules. You need to be able to place things in the right place at the right time. And that's not just because of regulation, that's because of the fact you might have an outage somewhere, and we've got various other bits that's coming in, but more importantly, you don't always want to have permanently on environments. So you might develop in the cloud, and then when it goes to production, you might decide that you need to run it on-prem. You need the portability to be able to move it. So that could be on-prem. You could deploy it across 2 hyperscalers at the same time to give you that kind of super high availability, super resistance to any kind of outage. And you need to be able to automate this. We've talked about infrastructure as code for years. In the OpenShift world, we talk about GitOps and how things should be fully automated. You should be at a place where you're utilizing GitOps, so none of your teams ever need to physically get into your production clusters. It is fully automated, and it's just pulling the right things that you know have had checks and balances all in place. This allows your teams, your organization, to accelerate your delivery pipelines, to get your services out in front of customers far quicker than you ever could before, with the stability that they expect and that you demand from all of your applications when pushing them out into the public domain. But why? Avoid operational lock-in. That ability to land things where you need to can allow you to move to the right environment that you need. And there are various reasons why you might need to move things to different locations, be that cost pressures, be that security reasons, be the fear the feeling that your blast radius could be too much. Unifying VMs and containers. Like I said earlier, there's a lot of conversation, and I suspect you, your teams, your organization, and you as management are very much saying we need to be more cloud native. We need to look at this, but you've still got teams looking after 20-year-old VMs and 20-year-old applications that cannot necessarily be put into a container. Here you've got the opportunity to treat your virtual machines in the same way that you treat your containers, starting to apply the good practices that you would expect for cloud native delivery. Consistent day 2 operations. Whether it's a virtual machine or whether it's a container, you can utilize the same tooling to get the same consistent results. Lifestyle flexibility, how you move things up, where they sit within the cluster, how tightly they are, the blast radius, the segregation that we provide via namespaces, whether there's east-west communication between things or it has to go north-south. We can bring all of that to your VMs as much as your containers. Resilient and exit options. Keep your options open. Very much the mantra of right workload, right location, right time. If you want to build, dev, test on-prem and then ship into the cloud because it protects your on-prem environment, and that's where the customers need to access it. That makes sense. If you think that actually it needs to sit on-prem and it needs to be more protected through your guards that you've got there, then you can dev, test, build in a cloud environment that allows you to scale up and down to save you your cost. Flexibility, choices, business regulatory things, depending upon politics in the world, it once again brings you that level of flexibility. But then also platform team leverage. It's a big conversation that we also have. And it's how the fact that your infrastructure engineers and your SREs can build platforms that get out of the way for your development teams, allowing your development teams to pick up quickly, pick and choose what they need to do without having to fight for a long time to get things set up. But still, we're the infrastructure team, and more importantly, your security team, and then on top of that, your FinOps team, your finance team. The guardrails are there in place to allow this rapid development, the ability to experiment, but without breaking the budget, without breaking security, and without causing problems in your core infrastructure. Standardized tools, be it your first cluster or your 100th cluster. You can literally build this where you have a consistent management, consistent security, and a consistent container registry, but it doesn't matter where your cloud lives. Cloud A, Cloud B, and the way that once the cluster is built, the way that everything deploys on top of that is the same. One platform, one operational model, a standard way to deploy, observe, and secure all of your workloads, particularly your critical workloads. Options that we've got: IBM Cloud, Microsoft Azure, Google Cloud, Amazon Web Services, and then there's a whole plethora of environments that you can land should you want it on-prem. We have Red Hat OpenShift in IBM Cloud, Azure Red Hat OpenShift, and Red Hat OpenShift on AWS. They are native OpenShift, managed OpenShift services to those hyperscaler. And then we've got OpenShift Dedicated, which is once again a managed OpenShift offering that is run by Red Hat on the Google Cloud platform. How does it work? We've talked about consistency. We've talked about the ability to make sure everything is delivered in a unified way. One platform, one way, one delivery. Argo CD, the core of this. With Red Hat Advanced Cluster Manager. This is your single pane of glass that allows your engineering teams, your infrastructure teams, your platform teams to see exactly what is going on and where it's going on. Be that on a ROSA cluster, be that on an OSD cluster, be that on an ARO cluster. You have the option to build your clusters however you want and import it in, or you can actually build the clusters utilizing ACM itself. But this ACM comes with all the policies you could want, the ability to control, to check, to make sure that your environment is aligning with the requirements that you need. So just to round off, a comprehensive platform for all of your workloads. If you want to modernize your applications, if you want to drive into your cloud native development, virtualization still there, still going to be needed for some time, but now you can align it with your ways, your thoughts, your processes that go to your cloud native development. But as you've just seen in the demo, that ability to actually leverage multiple cloud, multiple locations to move things, to test things, to allow you to integrate with what you need to. We also offer AI enabled applications. OpenShift itself is an application platform, so there are other tools that you can layer on top. Much like ACM is an application that you can lay on top, we have the ability to integrate AI with it. But also then we talked earlier about the commercial off-the-shelf stuff, how there are some builders of that refuse to go to containers. You can still continue using that while sticking to what you need to deliver in terms of cloud native. So OpenShift, managed OpenShift, brings you the ability to leverage security, leverage stability, leverage repeatability while moving towards a cloud native way of working while still being able to consistently deliver and support and deploy applications in VMs as you have been for many years. Also taking on the potential of repeating how you've been doing it for many years. I hope this has been of help to you. Hopefully this will help you understand the value that we bring of the hybrid cloud with virtualization and how that can actually help your teams to be able to deliver faster, better, and bring clearer value for you, your organizations, and more importantly, your customers. Thank you very much for your time.